So in this video, we're going to be talking about one of the most important reactions that alkanes undergo. Remember this, alkanes in general are very unreactive. So alkanes generally very unreactive. But there is one important reaction or class of reactions that they do undergo, and that's radical halogenation. So alkanes undergo radical halogenation. And to illustrate how that works, I'm just going to show you the simplest example. The simplest example would be radical halogenation of methane, and we're going to consider chlorination here. The overall reaction is CH4 plus Cl2. These are both gases. Gives chloromethane and HCl. And the standard enthalpy change for this reaction is negative 25 kilocalories per mole. Now this reaction is exothermic, but if you were to just mix methane and chlorine, diatomic chlorine gas, together in a dark room at room temperature, you wouldn't really get any reaction. So I'll say at room temp, no reaction. However, if you were to either irradiate it, so with UV light, so I'll symbolize that by H nu, or if you were to heat the gas mixture above 300 degrees centigrade, which I'll symbolize by delta, then you would get this reaction. And you'd also get like ethane as a minor side product. So I'll just write this minor, and I'll explain in a moment why you end up getting ethane as a minor side product. Or you'll see why by the end of the video. And to understand why this reaction does not take place at room temperature in a dark room, but does take place if you irradiate the mixture with ultraviolet light, or if you heat it, we'll have to take a look at the mechanism. So remember, this is a radical reaction, so you do have to actually furnish a radical for the reaction to occur. And that step's called initiation. So the initiation step is you break diatomic chlorine via homolytic cleavage. So this shared electron, in this shared electron pair, one goes to each chlorine atom. So what you end up getting is two chlorine radicals, each with one unpaired electron. And this step costs energy. This step costs 85 kilocalories per mole. And that's really why you have to either irradiate the mixture with UV light or heat it to over 300 centigrade in order to be able to furnish this radical. And it's this radical that's what's going to be used in the reaction. So this is just setting you up for the reaction. The actual steps in the reaction are called propagation steps. And you have two of them. So propagation step 1 is you'll produce one of the products. You'll produce HCl. So what this will look like is this chlorine radical will be reacting with methane here. and you'll homolytically cleave this CH bond. So you'll have methyl radical, and this hydrogen and chlorine will combine to give you HCl. See, that's one of the products in the overall reaction. And this step costs 2 kilocalories per mole. The second step in the main reaction, and by main reaction I mean that the initiation was just to furnish the chlorine radical from diatomic chlorine gas. But the second step here is this methyl radical will react with diatomic chlorine. So you'll have, I'll just write it like this, draw the unpaired electron there, here, and this will be reacting with diatomic chlorine. Again, all the reactions here involve homolytic cleavage, so only you don't have movement of a pair of electrons, you only have movement of one electron in each. In every pair, only one electron contributes to a bond. So you have one electron. Here you'll be forming, explain this in a second. So when you form the CH3Cl, this unpaired electron from the methyl radical contributes one electron to the bond, and the unpaired electron from chlorine radical, which splits off from diatomic chlorine, will contribute one electron to this CCl bond here. And you're left over with this chlorine radical that's split off from the diatomic chlorine. And this step is exothermic, -27 delta H reaction is -27 kilocalories per mole. You add the standard enthalpies for the first and second propagation steps. You get, so delta H reaction, I'll put prop steps 1 and 2, +2 -27 equals -25 kilocalories per mole. And you'll see that that'll equal that's the standard enthalpy of the reaction for the overall reaction. And the reason why, if you look at the bonds broken here in the overall reaction, let's ignore this minor product for a second here. You'll see that you form a CH3Cl bond and an HCl bond, and you break a CH bond. So this methane has 4 CH bonds. You'll be breaking one of them, right? And you're going to be breaking this Cl-Cl bond as well. So you'll be breaking one of these CH bonds, you'll be breaking this Cl-Cl bond, be forming this CCl bond in chloromethane, and forming this HCl bond in hydrochloric acid. And when you look at these propagation steps, you'll see that those bonds are broken, are the ones that are broken and formed. So propagation step 1, you are forming this HCl bond and you're breaking this CH bond in methane. In propagation step 2, you are breaking this Cl-Cl bond and you are forming this CCl bond. So here I'll write propagation step 2, breaking ClCl, and forming CCl. Propagation step 1, you're breaking CH bond, you're forming the CCl bond. So overall you see that you have a breaking of one CH bond and a ClCl bond and the forming of a CCl bond. Oops, this should be an HCl bond. In propagation step 1, you form an HCl bond. So you're breaking a CH bond and a ClCl bond, and you're forming an HCl bond and a CCl bond. And when you look at the overall reaction, that's exactly what's happening. You're breaking one of the CH bonds in methane, as well as the ClCl bond in chlorine. You're forming the CCl bond in chloromethane and the HCl bond in hydrochloric acid or hydrogen chloride, depending on the naming system you want to use. So the delta H reaction is reflective of these two propagation steps. Remember, the initiation step's just setting you up for the reaction. And another thing to be aware of here is that the radical furnished in one of the propagation steps is going to be used in the other propagation step. So propagation step 1 furnishes the methyl radical, and methyl radical is used as a reactant in propagation step 2. Propagation step 2 furnishes the chlorine radical, which is used in propagation step 1. So after initiation takes place and you form a few chlorine radicals, propagation steps 1 and 2 will continue in a cyclic fashion. So you'll have initiation, and then prop 1, prop 2. These will kind of cycle on and on and on and on until the radicals kind of bounce into one another and form the products of what's called the chain termination steps. And I'll show you what I mean by that right now. So let's say you have chlorine radical here and methyl radical here, right? So they can, and let's say you have a bunch of them. No, not just one. So two chlorine radicals can bump into each other, and you'll get Cl radical plus Cl radical. This will give you diatomic chlorine gas, right? Well, this is one possibility. Another possibility is you can have a methyl radical. So say this is like a reaction mixture. I'm just going to draw something that looks like a beaker. It's not necessarily taking place in a beaker. Well, actually, it's probably not. But it's just for illustrative purposes. So two chlorine radicals bump into each other, you get diatomic chlorine gas. If you have a methyl radical bumping into a chlorine radical, you'll get chloromethane. But alternatively, you could get two methyl radicals bumping into one another. And when that happens, you'll produce ethane. And So this is what chain termination is like. When you have one of these products formed, the reaction basically terminates. And now this is what's going to happen most often. This is the termination step that's going to happen most often, but you may get two molecules of ethane that bump into each other. And so you'll get, that's why I listed in the overall reaction this overall 1 second. When you look at the overall reaction, you see ethane listed as a minor product because that's one possible chain termination step. But the big picture is that you'll furnish a radical through initiation. These propagation steps will continue once you have radical present, chlorine radical present, will continue cyclically until one of these three termination steps happen. Remember, this happens most often. That's why CH3Cl is your major product. But these other two can happen. This will basically, if Cl bumps into Cl, you'll get diatomic chlorine, which is actually one of your reactants. And if two methyl radicals bump into one another, you'll get ethane, which is a minor product in the overall reaction. So you'll see it's a minor product. But that's the general mechanism that all radical halogenation reactions follow. I just showed you the simplest case using methane, and we considered chlorination of methane. But other radical halogenations are possible as well, and we'll get into those in subsequent videos.